Have you ever gazed upon a majestic mountain range, a winding river, or a vast desert and wondered how such diverse landscapes came to be? Our planet is a canvas of incredible geographical features, each telling a story of immense natural forces. These formations are not static monuments but rather dynamic results of continuous processes. Earth's surface is constantly being sculpted, eroded, and rebuilt by the very elements that sustain life. Nature possesses an unparalleled power to reshape planetary geography. From the smallest grain of sand to the largest continental plate, everything is in a state of perpetual transformation. Understanding these processes reveals the true dynamism of our world. It highlights how seemingly unchanging landscapes are, in fact, always evolving. The journey of geographical transformation often begins with weathering. This fundamental process involves the breakdown of rocks and minerals directly at the Earth's surface. Weathering occurs without the movement of the material itself. It prepares the ground, so to speak, for subsequent processes that will transport these broken fragments. Weathering is the initial stage in the grand cycle of rock transformation. It is the disintegration and decomposition of solid rock into smaller particles or altered chemical compounds. This process is crucial for creating the raw materials that will eventually form soils and sediments. It sets the stage for all further geological changes. Weathering manifests in several distinct forms, each with unique mechanisms. These types often work in conjunction, accelerating the breakdown of Earth's crust. Understanding these different processes helps us appreciate the complexity of landscape evolution. They are the silent architects of our world. Mechanical weathering, also known as physical weathering, involves the physical disintegration of rocks. It breaks larger rocks into smaller pieces without changing their chemical composition. This process increases the surface area of rocks, making them more susceptible to chemical weathering. It is a powerful force in many environments. One powerful form of mechanical weathering is the freeze-thaw cycle. Water seeps into rock crevices, and as temperatures drop, it freezes and expands. This expansion exerts immense pressure, gradually widening cracks and eventually breaking the rock into smaller pieces. It is particularly effective in cold, moist climates. Wind and water also contribute significantly to mechanical weathering through abrasion. Particles carried by wind or water collide with rock surfaces, grinding them down. This constant friction acts like sandpaper, smoothing and shaping rocks over vast stretches of time. It is evident in deserts and along coastlines. Chemical weathering involves the alteration of the chemical composition of rocks and minerals. This process transforms them into new substances that are often softer or more soluble. It is a more subtle but equally powerful force in shaping landscapes. Chemical reactions slowly dissolve and decompose rock structures. Various chemical reactions contribute to this type of weathering. Water, oxygen, and acids react with rock minerals, changing their fundamental structure. These subtle changes can significantly weaken the rock, making it more prone to physical breakdown. It is a pervasive process across all climates. Acid rain is a potent agent of chemical weathering. Atmospheric pollutants combine with moisture to form acidic precipitation. When this acid rain falls, it reacts with minerals and rocks, particularly limestone and marble, dissolving them over time. This process can cause significant damage to natural formations and human structures. Oxidation is another common form of chemical weathering, similar to rusting. When oxygen in the air or water reacts with minerals containing iron, it forms iron oxides. These new compounds are weaker and more brittle than the original minerals. This process often gives rocks a reddish or yellowish hue and contributes to their disintegration. Once rocks and minerals have been broken down by weathering, the next crucial step in geographical transformation is erosion. Erosion is the process of transporting these weathered materials. It is the dynamic force that moves sediment, soil, and rock fragments from one location to another. Without erosion, the Earth's surface would be covered in a thick layer of weathered debris. Erosion involves the detachment and movement of surface materials by natural agents. It is a continuous process that reshapes landforms on scales from microscopic to continental. This transport can occur over short distances or across entire continents, fundamentally altering the landscape. It is a key player in the Earth's geological cycle. Several powerful natural agents are responsible for the widespread phenomenon of erosion. Each agent operates with distinct characteristics and leaves its unique mark on the landscape. These forces work tirelessly, often in combination, to sculpt the Earth's surface. They are the primary drivers of landscape change. Water is arguably the most pervasive and powerful agent of erosion on Earth. Its ability to flow, dissolve, and carry material makes it an unparalleled sculptor of the land. From tiny rivulets to mighty oceans, water constantly reshapes our planet. Its influence is visible in nearly every landscape. The relentless flow of rivers and streams carves out vast valleys and intricate canyons. Over millions of years, water incises into bedrock, creating dramatic geological features. The Grand Canyon is a prime example of water's immense power to sculpt the Earth. Its sheer scale testifies to the persistent work of flowing water. Ocean waves and currents constantly batter coastlines, eroding cliffs and beaches. The energy of the water dislodges rock and sand, carrying it away. This process leads to the formation of sea caves, arches, and stacks, continually reshaping the interface between land and sea. Coastal erosion is a dynamic and ongoing challenge. Rivers are like arteries of the land, tirelessly cutting their paths through diverse terrains. They transport enormous quantities of sediment from mountains to the sea. This continuous action deepens and widens river channels, creating floodplains and terraces. Rivers are fundamental to the hydrological cycle and landscape evolution. Waterfalls are dramatic examples of water's erosive power. As water plunges over a cliff, it erodes the rock at the base, causing the waterfall to retreat upstream over time. This process creates gorges and contributes to the overall shaping of river valleys. Waterfalls are dynamic features that constantly modify their surroundings. Wind, though often less visible than water, is a significant agent of erosion, particularly in arid and semi-arid regions. It picks up and transports loose particles, shaping vast landscapes. Its erosive power is most evident where vegetation is sparse, leaving the ground exposed. Wind sculpts the land in unique and fascinating ways. One of the most iconic results of wind erosion and deposition is the formation of sand dunes. Wind picks up sand grains and deposits them in mounds, which then migrate across the landscape. These shifting dunes are characteristic features of deserts and coastal areas. They are dynamic landforms constantly reshaped by air currents. Beyond dunes, wind sculpts entire desert environments. It abrades rock formations, creating ventifacts and yardones, which are distinctively shaped rocks. The constant movement of sand and dust by wind contributes to the unique, often stark beauty of deserts. Wind is a powerful force in these dry regions. Glaciers are massive rivers of ice that move slowly across the land. They are incredibly powerful agents of erosion, capable of transforming entire mountain ranges and valleys. During past ice ages, glaciers covered vast portions of the continents, leaving an indelible mark. Their legacy is still visible in many landscapes today. Glaciers are not static but flow under their own immense weight. As they move, they pluck away rock fragments from their beds and sides, incorporating them into the ice. This process, known as glacial quarrying or plucking, is incredibly effective at removing large chunks of bedrock. Glaciers are truly geological bulldozers. One of the most distinctive landforms created by glaciers are U-shaped valleys. Unlike the V-shaped valleys carved by rivers, glaciers widen and deepen valleys into a characteristic U-profile. This shape is a clear indicator of past glacial activity. These valleys are often found in mountainous regions that experienced glaciation. Beyond U-shaped valleys, glaciers leave a variety of other distinctive landforms. These include cirques, arêtes, fjords, and moraines. Moraines are ridges of debris deposited by glaciers, marking their former extent. These features provide valuable clues about Earth's glacial history. Following weathering and erosion, the final stage in the cycle of material movement is deposition. This is the process where eroded material is laid down in a new location. Deposition builds up new landforms and layers of sediment, often in areas of lower energy. It completes the cycle, preparing material for future geological processes. Deposition occurs when the transporting agent, whether water, wind, or ice, loses energy. As its velocity decreases, it can no longer carry its sediment load. This results in the settling of particles, from large boulders to fine silt. Deposition is fundamental to the formation of sedimentary rocks in new land. Deposition creates a wide array of geographical features, each shaped by the specific agent and environment. These landforms are evidence of past and ongoing geological activity. They represent the accumulation of material that has traveled, sometimes vast distances. Deposition is a constructive force, building up the Earth's surface. River deltas are iconic examples of depositional landforms. They form where a river enters a larger body of water, like an ocean or a lake, and its velocity slows dramatically. The river drops its sediment load, creating a fan-shaped landmass of fertile soil. Deltas are vital ecosystems and often densely populated areas. Along coastlines, waves and currents deposit sand and other sediments to form beaches and sandbars. The energy of the waves sorts and moves material, building these features. Beaches are dynamic environments, constantly reshaped by tides, storms, and currents. Sandbars are submerged or partially exposed ridges of sand. Over vast stretches of time, deposited sediments accumulate in layers. These layers can eventually compact and cement together to form sedimentary rocks. This continuous buildup creates new landforms, fills basins, and contributes to the overall elevation of regions. It is a slow but powerful process of land creation. While geological forces are immense, living organisms also play a significant role in shaping Earth's landscapes. Biology and geology are intricately linked in this transformation. From microscopic bacteria to towering trees, life contributes to both the breakdown and buildup of geographical features. These biological influences are often overlooked but are profoundly important. Life on Earth is not merely a passenger on a preformed planet, it is an active participant in its ongoing creation. Organisms interact with their environment in countless ways. These interactions can accelerate weathering, stabilize land, or even construct entirely new geological structures. Biology is a powerful geomorphic agent. The impact of living organisms on geography is diverse and widespread. Their actions can be subtle or dramatic, but always contribute to the planet's dynamic nature. These examples highlight the interconnectedness of life and the Earth's physical processes. They demonstrate how biology shapes geology. Plant roots are powerful agents of mechanical weathering. As roots grow, they penetrate cracks in rocks, exerting pressure that widens and deepens these fissures. Over time, this root wedging can effectively break rocks apart, contributing to soil formation. Trees and other vegetation are silent rock breakers. Coral reefs are monumental structures built by tiny marine organisms. These polyps secrete calcium carbonate, forming vast underwater cities. Over millennia, these reefs grow to create new coastlines, protect existing ones, and even form entire islands. They are biological land builders of immense scale. Animals, from earthworms to prairie dogs, create burrows and tunnels in the soil. This activity aerates the soil, mixes layers, and brings subsurface material to the surface. These actions contribute to soil formation, modify drainage patterns, and can even influence erosion rates. Animal activity is a constant, subtle modifier of the landscape. While weathering, erosion, and deposition are continuous, often slow processes, some geological forces cause rapid and dramatic transformations. These events reshape landscapes in moments. Volcanoes and earthquakes are powerful reminders of the Earth's internal energy. They demonstrate the planet's capacity for sudden and profound change. Volcanoes are openings in the Earth's crust that allow molten rock, ash, and gases to escape. They are powerful creators of new land and mountains. Volcanic activity is a fundamental process in the Earth's geological cycle. It brings material from the planet's interior to its surface. Volcanic eruptions can create entirely new landmasses. When volcanoes erupt underwater, lava cools and solidifies, gradually building up to form new islands. The Hawaiian Islands are a prime example of this process, formed by successive volcanic eruptions over millions of years. Volcanoes are true land builders. Many of the world's majestic mountains are volcanic in origin. Repeated eruptions deposit layers of lava and ash, gradually building towering cones. These volcanic mountains are often characterized by their distinctive shapes and fertile soils. They are powerful symbols of Earth's creative forces. Earthquakes are sudden movements of the Earth's crust caused by the release of energy. They can cause rapid and dramatic changes to the landscape. These powerful events are a direct result of tectonic plate movement. Earthquakes are a stark reminder of the dynamic nature of our planet's interior. During an earthquake, the ground can shift dramatically, creating fissures, uplifting sections, or causing subsidence. Entire landscapes can be altered in seconds. These shifts can reroute rivers, create new lakes, or change the elevation of vast areas. Earthquakes are powerful agents of instantaneous geographical change. Earthquakes often occur along fault lines, which are fractures in the Earth's crust. The movement along these faults can create visible scarps and offsets in the landscape. These geological features are direct evidence of the immense forces at play beneath our feet. Faults are fundamental structures in the Earth's crust. Powerful earthquakes, especially those occurring near coastlines, can dramatically alter shorelines. Land can be uplifted or submerged, changing the sea level relative to the land. This can create new beaches, expose underwater features, or flood coastal areas. Tsunamis, often triggered by underwater earthquakes, also reshape coastlines with immense force. From the slow grind of weathering to the sudden jolt of an earthquake, nature is in constant motion. Our planet's geography is a testament to these ceaseless forces. Every mountain, valley, river, and coastline is a product of this ongoing transformation. The Earth is a living, breathing entity, always sculpting and reshaping itself. This dynamic and beautiful process creates the incredible diversity of landscapes we see around us. It is a continuous cycle of creation and destruction, building and breaking down. We are privileged to witness the results of these powerful forces. Let us appreciate the incredible diversity and ever-changing beauty of Earth's landscapes, a testament to nature's enduring power.